I'm a research scientist, and the research that I do at UCL is in a very new field of science called astrobiology. It's all about the possibility of there being life beyond our Earth. It's the science looking into the feasibility of extraterrestrial life, or hunting for aliens, to put it another way. Now, my research focused primarily on a whole category of bacteria living in some of the most extreme environments on planet Earth, like the one we can see here. This is in Antarctica, so right down by the bottom of the planet, down by the South Pole. And this region, called the Dry Valleys, is very, very cold, as you'd expect in Antarctica, but also incredibly dry. And in fact, about the only water you can see in this landscape is in the caps, the snow caps, the mountains you can see in the distance, and this frozen over lake you can see on the valley floor. And these lakes are frozen over all year round. It's an incredibly dry environment, far, far drier than the Sahara Desert. Now, these dry valleys, for decades after they were discovered, were thought to be sterile environments, one of the very few places on Earth where there is no life whatsoever. And certainly there's no animal life or plant life that can survive in this habitat, in this environment here. But these dry valleys aren't dead, they are alive, there's life here. It's microbial life, and it's living underground, or more to the point, it's life living inside the rocks themselves. If you were to pick up one of the pebbles or rocks strewn across the valley floor here in Antarctica, smack it open with a rock hammer and have a look inside, you'd see a thin band of green, a smear of life, of chlorophyll, of bacterial plants, of cyanobacteria living just beneath the surface of that rock. So they're living inside the rock to protect themselves from the cold and the dry and the ultraviolet conditions. So the bacteria thriving here in Antarctica have got the right set of survival skills to be able to survive on the very cold, dry environment on the surface of Mars. It's one of the most Mars-like places we have here on planet Earth. So I've been culturing bugs, bacteria, from this environment, getting them nice and healthy in the lab, growing up to high populations, and then smacking them with high doses of gamma rays to try to get them to die again, because then I know what their radiation resistance is like. Because as well as being very cold and dry, the surface of Mars has been constantly bombarded with some very nasty radiation from outer space. So I'm looking into the kind of hardiest life forms here on Earth and comparing them to the environments on places like Mars to see how well they might fare. What might be the feasibility of discovering kind of dry valley type bacteria on the surface of the red planet. Now, these bugs are just one example of a whole category of organisms we've come to know on our home planet, on Earth, known as extremophiles, life living in the most hostile, inhospitable, extreme environments here on our world. And some examples here are life thriving in very hot, boiling acid in lakes of volcanically heated water in places like Yellowstone Park, or very cold-loving bacteria living in very salty water, running in veins throughout solid icebergs at sub-zero temperatures, or living in very, very dry deserts like the Atacama, you see in the bottom left here, or perhaps even sometimes very complex extremophile life forms, like the tube worms we find huddled in oases around black smokers, around the hydrothermal vents on our sea floors, miles deep away from any penetration of sunlight. And these extremophiles essentially define the limits of life on Earth. They define the outer limits of what life on Earth can survive. And the astounding thing about these survival superheroes from Earth is that they can survive the environments we know we think exist on other worlds. So places like Mars. And Mars is the place, I've already hinted, is the planet I'm focusing on. It's our next-door neighbour planet. And in many respects, Mars is the most Earth-like place in our solar system. We know for a fact that billions of years ago, when we were first getting started here, when life was first finding its foothold on Earth, Mars itself was very warm and very wet. We know for a fact that it had seas and lakes and rivers of liquid water gushing across its face. It would have had a much thicker atmosphere to insulate and shield the planet. And it would have had organic molecules that the building blocks of all life as we know it, raining down out of the heavens aboard meteorites and comets, in just the same way they did onto Earth and potentially gave us a foot up, a leg up. So there's no reason to expect that Mars will have its own genesis of life. And we want to go there. In fact, we have already gone there since the 70s with generations of Mars probes driving across the dusty landscape and looking for signs of life,
for Martian bacteria. Looking beyond, through the outer solar system, beyond Mars and the asteroid belt, we come to Jupiter. Now, Jupiter's the big daddy of our solar system. It's something like 300 times larger than the Earth, but it's a bloated gas giant. It's more air than anything else, and it doesn't provide any kind of environment for life as we could ever understand it to get started on. So it's not the planet Jupiter itself that we're interested in the possibility of alien life. It's the moons of Jupiter. These 4 giant moons, or the Galilean satellites, moving out from Io, the innermost moon, out to Callisto, the outermost moon. And just by looking at these moons, you spot something very curious about them. Io, the innermost moon, is a bright orangey yellow. It's the colour of angry sulfuric sulfur, yellow sulfur. And so Io is a violently tortured and hot place. It's more volcanically active than even the Earth, and it's constantly vomiting itself inside out, hot volcanism. Contrasting against that is Callisto. Callisto is still pockmarked and scarred with all the impact craters from the very earliest era of our solar system, and all the rubble left over from the making of the planets was still flinging around and smashing down into stuff. So Callisto hasn't changed its face in billions of years of our solar system's history, compared against Io, the innermost moon, which is very hot and violent. And in between, we find Europa. We think that Europa is a lovely, warm, wet world, but beneath its face of frozen water ice, there lays an ocean, a dark, alien ocean with more water in it than all the seas and lakes and rivers and oceans of the whole of the Earth put together. It is Europa that is the water world of our solar system, not the Earth. And as astrobiologists, as explorers, we would dearly like to land some kind of robotic probe, a lander, onto the surface of this ice shelf, and then drill or melt away through perhaps several kilometres of ice, just as the Russian scientists have just done to Lake Vostok in Antarctica, and get down to that liquid water, get down to that alien ocean, release some kind of automated submersible probe, and explore that alien ocean to perhaps look for things like black smoke as hydrothermal vents on the sea floor, which, as I've mentioned, represent oases of life in the dark depths of our own oceans. Now, looking beyond our own solar system to our galaxy, the galaxy we live in as a whole, the Milky Way. A couple of years ago, we launched this. We launched the Kepler Space Telescope. Now, Kepler is quite a lot like the Hubble Space Telescope that you may have seen the pictures from, that's beamed back down to the Earth. But unlike Hubble, Kepler has one job and one job only. For its entire lifetime, its entire mission of several years, Kepler has been instructed, it's been ordered to stare at the same tiny patch of the sky. It never gets to look around at different galaxies or nebula planets. It's staring at the same place in the night sky. And Kepler, as we see in this map of our galaxy, and where we are right here, that's Hull, just there. And that yellow triangle is where Kepler is looking. It's peering back along the spiral arm of our galaxy. It's been deliberately pointed to a place in the night sky where there's lots and lots of stars all packed closely together. So for 3 years of its mission, Kepler is going to be monitoring about 150,000 stars simultaneously, waiting when some of those stars blink back at it. Because if a star blinks back at you, there's a good chance it's because a planet has just passed across its face and blocked out some of that starlight. So you can use this transit method, it's called, as a very, very effective way of discovering new worlds, orbiting other suns in our neck of the woods, in our part of the spiral arm of our galaxy. And Kepler is expected to discover thousands upon thousands of new worlds in the next couple of years. But of most excitement, of most importance, Kepler is expected to discover a very special kind of world indeed. A second Earth, a twin of our home world, an Earth-sized planet orbiting a sun-like star with an orbit of exactly 1 year. Right, it's the same distance from the heat of its campfire as we are from ours. It's not too close to its star and hot, it's not too far away and cold, it's just right. It's in what's known as the Goldilocks zone of its star, or the habitable zone, and it'll have liquid water and oceans and rivers on its surface, and the best possible chance for life to have got started and maintained on this world. So really, guys, watch the newspapers. This discovery of a twin of our planet is expected in the next 2 or 3 years. And in the following years after that, perhaps within 2 decades, 20 years, we'll have not just discovered that that planet is there, we'll have characterized it. We'll have gathered the light coming from that planet rather from its star and analyzed it and looked at the fingerprints of different gases in its atmosphere. We'll have read its atmosphere and hopefully found things like methane and oxygen, because those are the signatures of life on that planet. And I think that would be the most profound discovery we could ever hope to make. I think that would trump everything else in the history of science. You'd be able to walk out into your back garden with your neighbours or your children or your parents, your brother and sister. You could point to a particular place in the night sky and say, there is a star with an Earth-like planet orbiting it where we know there is life. But I think as well as being the most profound discovery we could make, it would also be the most frustrating knowledge. We would know there was life on that planet that we can see there, or at least the star that we can see, but we couldn't feasibly get there. It would take us hundreds and hundreds of years to build a spaceship capable of travelling across the gulf of space to that planet and be able to explore it closer. Now, the final idea I want to leave you with is this photograph here. This is known as the Hubble Deep Field picture. And I think it's quite possibly the most profound, the most important photo that's ever been taken in human history. It was taken by the Hubble Space Telescope a couple of years ago, when the telescope didn't have any observations booked. And the mission planner of Hubble said, well, all right, let's take this most advanced and sophisticated space telescope that we've ever built, and let's point it to a place in the night sky where we can't see anything at all. Let's point Hubble between any of the stars that we can see, and let's just see what's there. So for an entire 10 days, this Hubble whirled around and around and around the Earth in its orbit, fixated at the same tiny patch of night sky, just like a thumbnail held at arm's length. And it collected, bouncing off its mirror, these photons of light that have travelled to the best part of the age of the universe, reflecting off its mirror and being picked up in the Hubble detector. And it built up this image, photon by photon. And now pretty much every fleck of light you can see in this picture is a galaxy in its own right. These aren't stars we're seeing, they are entire galaxies, assemblages of hundreds of billions of stars, and as we now know from Kepler, probably an even greater number of planets. So surely, somewhere out there, there must be the right kind of world, orbiting the right kind of sun, with the right kind of conditions, the right kind of atmosphere, the right kind of ocean, the right kind of chemistry for life to have got started. We surely can't be alone in this vast universe around us. But as a scientist and astrobiologist, I don't care, to be honest with you, about life on a galaxy far, far away. I'd be so much more excited if we could discover that life was commonplace. If there were plenty of wet rocks out there smeared with life. If life was commonplace. Or perhaps if even some of the neighbouring worlds in our solar system also possessed biology. Places like Mars or Europa that I've just spoken about. Because these are places we can feasibly go to in our lifetimes. First with robotic probes, and then hopefully in the not too distant future with us, with humans, with astronauts. We'll go to Mars, find promising samples that may contain signs of life, bring them back to Earth, hopefully find fossilized, if not even extant, life that's survived or been preserved on the dusty surface of Mars. Reanimate that life, analyze it, scrutinize it, see how it works, find out ways that life is similar to us. But I think most exciting of all, see how this alien life is different from us, how it's built in a fundamentally different way. Because I think by doing that, we'd end up learning an awful amount about ourselves and our place in this vast cosmos around us. Thank you.